Welcome to TET Academy. In today's video we will be focusing on Chapter 1, Operations and Productivity. Objectives. By the end of this video, you will know what operations management is and supply chain management. You will know the distinction between goods and services and also be able to explain the differences between production and productivity. Then you will know how to compute single-factor productivity as well as computing multi-factor productivity. Let's get started. What is operations management? Is the discipline of overseeing, designing, and controlling the processes that turn resources, such as people, materials, and technology, into finished goods or services. Effective operations management practices prevent a business from wasting time, money, and resources. Operations management involves managing and optimizing the processes that transform resources into products or services, ensuring businesses run efficiently, profitably, and with quality. Meaning that operations management directly impacts key business outcomes like profitability, productivity, customer satisfaction, and compliance. What is supply chain management? It's about managing the flow and storage of stuff. The materials, data, inventory, goods, and finances, as they move from start to finish. Think of it like from the supplier to the customer. Here is the difference between the two: operations and supply chain management. So, operations management is like the engine of a business, focusing on the internal processes that create and deliver products or services. Supply chain management is more about the network of external partners and flows that get stuff from point A to point B. Think of operations as how, and supply chain as the who and where. What does operations managers do? They are responsible for planning, organizing, staffing, leading, and controlling. Moving to the differences between goods and services. This is a tabular form explaining the differences clearly. Characteristics of services and characteristics of goods. So, services are intangible. Example can be a ride in an airline seat, while goods are tangible, example being the seat itself in an airline. Services are consumed and produced simultaneously. Products are usually kept in inventory. Examples of services again can be when you are consulting or receiving education, meaning that service is high in customer interaction compared to goods because the customers aren't super involved in how they are made. Services are inconsistent product definition, meaning the quality or specifications are not always the same while goods are product standardized. Services are often knowledge-based and goods tends to make automation feasible. Service is spread out. Think of a bank with multiple branches. Then goods are typically produced and stored in one place, then distributed out to customers. Think of a factory, making clothes, then sending them to stores. Talking about quality in services may be hard to evaluate, while in goods quality is easy to evaluate. Production and productivity. What's the difference? Simple. Production is the creation of goods and services. Productivity is a measure of how efficiently inputs, your labor, capital, and raw materials are being utilized in an economy or business to produce a given level of output. The mathematical formula in business and operations is expressed by the following equation. So, output is your numerator is the top, and it is the quantity of goods produced or service rendered. Then input is your denominator on the bottom, which will then be your resources. Computing single-factor productivity. Know that one resource input is a single-factor productivity. To calculate single-factor productivity, you measure the output of a process relative to a single specific input like labor, materials, or energy. Here are practical examples to get you understand. Example 1. Labor productivity. A call center team handled 1,200 customer inquiries in a single 8-hour shift with 5 employees. The 1,200 inquiries will be our output, then input will be the labor, of which is the 5 employees multiply by 40 labor hours. Calculation. 1,200 divides by 40, then we get 30. Results are that the labor productivity is 30 inquiries per labor hour. Example 2. A bakery uses 200 kilograms of flour to produce 500 loaves of bread. In this case, our output value is 500 loaves, and our input is the material, the 200 kilograms of flour. Calculation. 500 divides by 200, then the answer is 2.5. If we were to interpret that, we will then say, the material productivity is 2.5 loaves per kilogram of flour. Example 3. Machine productivity. A textile machine produced 4,000 meters of fabric while consuming 800 kilowatt-hours of electricity. The output is 4,000 meters, then energy will be the input, the 800 kilowatt-hours consumed. Calculation. 4,000 divides by 800, the answer is 5. Result, the machine or energy productivity is 5 meters per kilowatt-hour. Our last objective, computing multifactor productivity. Note that multiple resource input is multifactor productivity, also known as total factor productivity. Another thing is output, and inputs are often expressed in dollars. So, multifactor productivity measures how efficiently a business uses a combination of inputs to produce output. The mathematical formula to calculate multifactor productivity: make sure to convert the inputs into a common unit, usually currency, so they can be added together. Here is the formula. Now let us check the examples. Number 1. An electronic assembly plant produces 1,000 tablets per month. So, each tablet has a market value of $300. Here the output value will be 1,000 tablets multiplied by their market value, the $300. Then the inputs are the labor costs, material costs, and energy or overhead. So, labor will be 80,000, which will be given to you, materials 120,000, and overhead of 20,000. Calculation. 300,000 divides by inputs, 80,000 plus 120,000 plus 20,000. You should get 1.36 as your answer. Result is that the plant generates $1.36 of value for every $1 spent on combined resources. Example number 2. A large-scale laundry facility processes 20,000 kilograms of linen for hotels. They charge $2 per kilogram. Output value will be 20,000 kilograms multiplied by $2, then inputs will always be given. In this example are labor costs, chemicals, and machine capital. Labor costs are 12,000, chemicals are 6,000, and machine capital is 4,000. Calculation. 40,000 divides by the inputs, the 12,000 plus 6,000 plus 4,000. You should get 1.82 as your answer. Results: the laundry service generates $1.82 of value for every $1 spent on combined resources. Become part of our vibrant Academy family by hitting the subscribe button and don't forget to like and share. Thank you for watching.